Hi, everyone. Welcome back to my spiritual journey. My name is Dave Thomas Rocker. I haven't made one of these videos in a while, but today, well, first I want to give a plug for my book called My Spiritual Journey. As I've mentioned in my other videos, this is a book I published this summer, and it's available on Amazon, both in Kindle and in paperback, and I think you should check it out. Anyway, let's get started with today's video. So today I'm going to talk about dogma, scientific dogma in particular. I think I kind of beat up religious dogma enough in a previous video, and I think we can all kind of agree that any form of dogma is bad. But I think the point I'm trying to make tonight is that there's also a lot of scientific dogma and other forms of dogma. So it's not just religious dogma that's the enemy, it's all forms of dogma. And there was a famous scientist named Freeman Dyson who has a very good quote about scientific dogma. He said, you can read it, but basically he says that dogma is just arrogance when people think they have absolute knowledge or something, or they're preaching absolute knowledge that you can't question. That's kind of the definition of dogma. And there is a lot of that on science, unfortunately. Even though science is supposed to be open-minded, like you're supposed to be falsifiable, I mean, you're supposed to. That's what Karl Popper said. Science isn't science unless it's falsifiable, meaning that you never have the absolute knowledge of science. There's always the possibility that you could perform an experiment that's going to refute your theory, or at least parts of your theory. So we have to be humble enough to realize that. And there's another famous quote. This is from Helen Fadarin. She said, "When science can no longer be questioned, it's no longer science," which is basically what I've been saying. So, anyway, I want to give some examples of some dangerous scientific dogmas that we've had through the centuries. And I think, pretty obvious one was social Darwinism. I mean, Darwin was very badly misinterpreted. As you all know, Charles Darwin, he came up with a theory of evolution by natural selection, which I think is a real scientific theory, and there's plenty of evidence to back it up. But the way it got interpreted in the 19th century, unfortunately, was that it was a way of kind of defending this racist view that white people were superior, African Americans, because we were more developed. We invented civilization and modern technology first. They were still living in the jungles, and I don't believe that at all. I think that's a very bad misinterpretation of Darwin. I mean, first of all, evolution isn't like a line. It's more like a tree. So I think it's better to say that maybe the whites are one small branch of the tree and African Americans are on another small branch. It doesn't mean that one of us is superior or inferior to the other. And I think that was just a very bad misinterpretation and ended up getting used very badly. And Another bad theory. I mean, if you want to look at what the bad that came out of social Darwinism is kind of obvious. Eventually, I think it led to fascism, and then kind of on the other extreme, you had environmental determinism, which was actually interesting because that was also, I think, developed in Britain. And this kind of said the opposite. I think both of these dogmas kind of defended Britain. Because one of them said, the British people were white and we're superior because of our genes. The other theory, environmental determinism, said that, because we live up north where the weather's not as good. People have to work harder. People live in the tropics. They have sunny weather all the time, so they're not going to want to work. They're going to want to just take it easy in the jungles or on the beaches or whatever. And I think a lot of people believe this, and certainly it favored the English, and I think it even kind of favors the Americans in some ways too. But that and it's kind of interesting because for a long time there was this nature versus nurture debate. And I always thought it was a pretty stupid debate. I mean, the debate was all about which of these two bogus theories was right. Like, is our evolution, our behavior, is it determined by our genes? Like, are we just superior people with better genes better off? Like, well, could we breed better qualities? Which is kind of what I think the Nazis tried to do with the Aryan race. Or, because it is the environment kind of the determining factor of who we become. And if you take that to the extreme, that kind of leads to, communism in a lot of ways because you're trying to control the environment that people live in. You're trying to provide, the ideal environment for people to thrive, and you're denying them the kind of environment they want to live in. And so I think both of those theories, they're both very extreme, and they've been practiced as dogmas, and I don't think either of them are right. I think both factors are important. I don't know which is more important. I sort of lean on the side of the environment, but I think they both contribute to who we are. I don't think it's one or the other. That's why I always thought it was a stupid debate. And, another very bad form of scientific dogma had to do with, denying the existence of atoms and molecules. I think it was a really ridiculous one because as early as around the turn of the 19th century, I think it was Dalton. Dalton came up with the atomic theory. I mean, first the Greeks. There was a guy named what was his name? The guy came up with the atomic theory. His name escapes me right now. It was like 500 BC. It wasn't a science. He was just a Greek philosopher. No, Democritus. That's right. He just guessed that matter was made of these indivisible particles called atoms. It turned out he was right. They weren't indivisible. He had the wrong idea what they were. He thought they were platonic solids, or at least Plato did. But he had the right idea that matter was composed of atoms. And I think the first sort of scientific theory that kind of gave credence to that idea didn't quite prove it, but there was a guy named Dalton around the turn of the 19th century that came up with atomic theory. And it was based on some scientific evidence. It was based on chemistry, basically. I mean, law of proportions in chemistry. You put a certain number of moles of one chemical together with a certain number of moles of the other chemical, and that balances everything. All the reactants react, and you're left with a single product. And if you don't use the right proportions, you get one of the other ones left over. I mean, that was already known. And I think Dalton had a very good mechanism for explaining that, which was atomic theory. Even though nobody saw an atom, it made sense. And I think there was more and more evidence for the existence of atoms throughout the 19th century. I mean, another big proponent and another big kind of source of that evidence was Mendeleev. He discovered the periodic table of elements, and he discovered that elements in a certain column of the table had the same kind of properties. And that made much more sense if atoms existed. And, but even besides all this, it was pretty clear, I think, that atoms probably existed and molecules too, because they were compounds made of elements, which had the individual atoms. So that was already in place. But for whatever reason, I don't know what it was. The consensus around the turn of the 20th century, at least by most of the leading scientists in the world, was that atoms and molecules didn't exist. I don't know where they came up with this conclusion. I guess because they never saw one. Maybe they thought it was a convenient fiction about something we'd never seen. But the tragedy of all this is that there was a really great physicist named Ludwig Boltzmann. He was a German physicist, and he came up with a very important physical theory called statistical mechanics. It kind of explains everything that was already known about thermodynamics. But thermodynamics was more of an empirical science. I mean, it treated gases, ideal gases, with just three quantities: pressure, temperature, and volume. And the nice thing about statistical mechanics, which Boltzmann discovered, was he started with this model of atoms and molecules, and he was able to prove everything using that model that was already known about thermodynamics. So he kind of came up with a mechanism for thermodynamics. But what ended up happening was, since the scientific community didn't believe in atoms and molecules, they wouldn't accept his theory, and he took it so hard he ended up killing himself in 1906. It was very tragic because another thing was really tragic about it was just a few years later, maybe 3 or 4 years later, that Einstein discovered so, Brownian motion. He came up with a paper explaining Brownian motion is due to the motion of atoms and molecules, and there was other theories that kind of indicated that. And just by I think 1909 or 1910, the scientific community had no choice but to agree that atoms and molecules existed. So, very tragic death for Boltzmann. But, one thing I think is interesting about all this is that this is the most famous formula he came up with, S equals K log W. I mean, part of his theory kind of verified the second law of thermodynamics, the idea of entropy, why it's always increasing. And that was his most important formula. And they put it on his tombstone, to honor him. But anyway, that was a very bad dogma that it led to his suicide, and it was among scientists. And I think the latest dogma, and I think this is a dogma, is string theory. And everybody got really excited about string theory. The first string theory revolution was in 1984. I started graduate school in physics shortly after that, I think 85. And I wanted to learn string theory. It was supposed to be the theory of everything. It was just kind of the holy grail of physics. I mean, this is what Einstein spent the whole latter half of his life trying to find. It wasn't called string theory. There's two more forces that weren't known when he was developing his theory. He was just trying to unify gravity and the electromagnetic force. And it's a nice thing to believe in that all the forces in the universe all unified into one theory. And string theory looks like it wants to be that theory. But the problem with string theory, I think the biggest problem with string theory, is that it's not science. There's absolutely no scientific evidence for any of it. I mean, some of it looks really beautiful. And, the thing is, there's a lot of physicists who are still studying this stuff. They're determined that it's real science, but they have absolutely no evidence for it. And until they get some evidence, I don't even think it's science. I think it's more like medieval theology. But a lot of, I mean, the fact that it seems like theology rather than science, to me, seems to indicate that the people who are still adhering to it, they're guilty of the same kind of scientific dogma, just believing this stuff because they want to believe it, which basically is dogma. So, we still have scientific dogma. I'm sure there's a lot of other forms of scientific dogma that I haven't even talked about. But, I guess my only point tonight is even though I do, I have been very well trained in science and reason, and science is supposed to be based on reason rather than faith. Even though I've always, believed in science, and maybe there's not as much scientific dogma as religious dogma. I think the main point I'm trying to make tonight is that any form of dogma is bad. I mean, we can't claim that we're absolutely certain about anything in the universe. There always has to be room for doubt. And if there's no room for doubt, then it's a dogma. And we have to be humble enough to realize there's room for doubt and we can't know everything. We can't possibly know everything about anything. I mean, that was proven. That was mathematically proven by a guy named for uh for Gödel in 1930. He had a mathematical theorem called the what was it called? Um, the incompleteness theorem, Gödel's incompleteness theorem, which mathematically is a mathematically proven result that says we can't know everything about math. And that was a big shock. I mean, math. I mean, to me, math is the most absolute discipline there is. I mean, two plus two is four. There's just no way around that. And you can prove everything very rigorously in math. But Gödel showed that there's things we're never going to be able to prove, even in math. So we have to be humble enough to realize that we can't know everything about anything, math or science or logic. There's always room for doubt, and we have to always start with a set of axioms anyway, even in math. You can't prove anything, and unless you start with some assumptions. That goes for math or science or religion. So down with dogma. And I think that's the last thing I want to say tonight. And thank you for watching. I hope you enjoyed the video tonight, and I'll see you next time.